Hi, my name is Alicia, and I'm the Library Service Associate here at the Cliff Wright Library. I want to welcome you all to the Sustainability Speaker Series, and thank you for coming out today. So now we are gathered today on the Treaty 6 territories and the homelands of the Métis. On behalf of the Saskatoon Public Library, I would like to pay my respects to the Indigenous ancestors of this place. As an organization that played an important role in the settlement of Saskatoon, and as a key memory institution, we acknowledge our responsibility to respond in meaningful ways to the calls of action. The program tonight can only happen because of the partnership the library has with the Saskatchewan Environmental Society, who work hard to find knowledgeable speakers month after month. I invite Katya from the Saskatchewan Environmental Society to come up and introduce tonight's speaker.
Thank you. Good evening, everyone. My name is Katya Gudkova. I'm one of the organizers of Sustainability Speaker Series, and I welcome everyone to today's presentation for October. Before I introduce our speaker, I want to say a few words, as usually, about the Saskatchewan Environmental Society. So, SES has been operating since 1970s, advocating for nature protection and conservation, doing environmental policy reviews, combating climate change, among many other areas of focus. Saskatchewan Environmental Society also delivers community education, outreach, undertakes research, and carries out demonstration projects that move us towards sustainability. If you aren't already a member, I encourage you to join. You can find out more about our diverse projects, activities, and how to get involved at our website, environmentalsociety.ca. Our speaker tonight is Dr. John Pomeroy. Dr. Pomeroy wears many hats. Just some of his positions include Distinguished Professor and UNESCO Chair in Mountain Water Sustainability at the University of Saskatchewan. He's a director of many organizations and programs. So one of them is Global Water Future Program, director of Center for Hydrology, Cold Water Laboratory in Canmore, Alberta, and Smart Water Systems Laboratory in Saskatoon. John Pomeroy also serves as adjunct professor at the University of Waterloo. For the World Climate Research Program, Pomeroy leads International Network for Alpine Research Catchment Hydrology Project. He co-chairs the UN Advisory Board on the International Year of Glaciers Preservation 2025. John is a fellow of the Royal Society of Canada, American Geophysical Union, and Royal Geographical Society. His primary research interests are snow and glacier hydrology, the impact of land use and climate change on hydrology and water quality, and improved observation and prediction of climate change impacts, especially floods and droughts. Even though being such a busy person, John Pomeroy is still finding time for camping, hiking, canoeing, kayaking, cross-country skiing, and reading books. So tonight, John Pomeroy is going to talk about saving our vanishing glaciers. So please join me in welcoming our speaker.
Well, thank you very much, Katja, for the kind introduction, and thank you to the library, to the Saskatoon Libraries, and the SES, the Environmental Society, for inviting me here. And as many familiar faces in the crowd, many I haven't seen for a long time, and I think two people were on trip I was on in 1979 where I first saw glaciers in the Rockies for the first time. So it's kind of cool that there's a few still hanging around from those days. Anyway, so I posed a question in the title. You'll get the answer pretty quickly, unfortunately. I won't spoil it, though, and we'll get into it. But I want to cover not just the glaciers, but the snow and ice and other aspects of that strongly affect our water supply and our climate and our oceans and our whole livelihoods around. And so we'll get into that. But first, we'll get into why are we worried about glaciers in the first place. And the worry stems from the changes in the Earth's temperature since the mid-1800s. And this is a climate reconstruction from the Hadley Centre of the UK Met Office and the Climate Research Unit at the University of East Anglia, because thermometers were not widespread in the past, so you need proxy measurements such as tree rings and lake sediments or bubbles in ice to figure out the temperatures when there weren't reliable temperature measurements in the past. And that's why this temperature chart has more uncertainty and wider widths as we go into the past. Before there was a good global network of thermometers that were registering and collected reliably around the world, sort of from the 1960s onwards. But the key thing here is that in the 1800s, the temperatures were anywhere from a quarter to half a degree cooler from what they were sort of in this average period from the 1950s to the 1970s. And but also at that time, one of the most potent greenhouse gases, which is carbon dioxide, its concentrations were 285 parts per million, and that. So there have been variations in this going before that, but this carried on for quite a long time, and then this rapid change started to occur in the early 20th century. By the 1950s, carbon dioxide levels had passed over 300 parts per million, and temperatures had risen almost half a degree at that point. And then there was a rapid warming that started in the 1970s, and that's where things really took off. And that's where we see the degree of warming now, which is over 1.5 degrees higher than it was in the 1800s. And the most recent carbon dioxide measurement is around 425 parts per million. So it's half as high as it was in the 1800s, or a third as high as it was in the 1950s and early 60s. And that's carbon dioxide is one of the principal greenhouse gases. So we haven't seen carbon dioxide concentrations like this as humans ever. The previous high concentrations of this level occurred before Homo sapiens had evolved. So we're talking millions of years now. So the climate that will result from that is not one that we've seen as a species, and that creates an existential crisis for us in terms of how we manage our planet, our ecosystems, and everything from sea levels to water supply to droughts and on. But it also has a tremendous impact on glaciers, because most of our glaciers we see are remnants of the Ice Age, and they had a small advance in the Little Ice Age period, which followed the medieval warm period in the 1300s to kind of ending in the early 1800s. And many of them had advances in that period, but then rapid decline ever since. So if we go up to the current time and look forward, we see that even more warming is projected. And how much is projected is a bit uncertain, because it depends upon human actions. And those actions include controlling the emissions of greenhouse gases through effective treaties, meeting the agreements that were made in Paris 10 years ago. So we could do things like that. Or we could drill, baby, drill, and carry on with fossil fuel emissions. And that's sort of a business as usual scenario that is, many scientists refer to as this SSP. It's 8.5, but it leads to massive warming. So if we look at the temperatures for the 2020s to 40s and 2040s to 80s and 2080s to 2100, with red being much more change, we can see that in the near term, Canada is warming up, and we're seeing that already. Medium term, much more, but even more at the highest latitudes. So the Arctic is going to warm more than the more temperate regions. And long-term change, by the end of the century, we're seeing temperature increases in these models of 8 to 10 degrees Celsius above what we've experienced. Now, we've already warmed in Canada more than the global average, and we're warming about twice as fast as the global average, but the north is warming 3 to 5 times as much. And so that's a pretty distressing scenario in there. That really means a climate unlike anything that we've seen in Canada in any recent settlement of the country. But there's also changes to precipitation. So as a hydrologist, I'm very interested in that. And here we see Canada mostly is wetting up. It's getting more precipitation in the future, along with warming. But that, when we look into the details of that precipitation, a lot of it's coming as rain, not as snow, and it will be coming in the winter and spring, and much less in the summer quite often. So that is going to pose challenges for places like Saskatchewan, where we could see substantial declines in soil moisture in the summertime, which will make it difficult for a lot of our crops that currently are planted in the spring and expected to grow with summer's rainfall. That'll be more difficult, but maybe it creates opportunities for winter wheat and other crops that we haven't even thought of yet. So that's some of the backdrop to what we're seeing. But this intensifies the hydrological cycle. It means more rainfall, more floods, longer droughts, greater increases in stream flow, but also more intense periods with low flows. But for the snow and ice around the world, the implications are very clear. It's a very bad time to be a snowman. And the loss of snow and ice is very confident from these models. So we'll go back. So when we look at, in detail, Western Canada's water future, we've tried to forecast what some of the changes would be in the Saskatchewan River Basin, and we think new crop varieties, northward expansion of agriculture as long as soils permit, significant loss of mountain glaciers, loss of a lot of the mountain forests because of fires, northward expansion of grasslands into the boreal forest, loss of much of the evergreen needleleaf forest in the boreal and subarctic due to wildfires. And we were suggesting this 6 years ago, but certainly the last few years are unfortunately on track for that. And then also for the human aspects, more rain on snow-driven flooding in the mountains, reduced glaciers, so more droughts, and in our rivers, which come from the mountains. 99% of the South Saskatchewan River's flow rises from Alberta, and of that, 70 to 80% is coming out of the mountains. So what we see in the South Saskatchewan River here in Saskatoon is really a mountain river. It's what is often called an exotic river, almost like the Nile, in that it's traveling through a very dry area from a very wet area here. But those changes in the mountains are going to cause problems downstream. And at the same time, because of problems with farming and pressures on dryland farming, we expect increased demand for irrigation, and this is exactly what the province has proposed, and Alberta has proposed as well, and possibly new reservoirs in the area, and more drying in the forest and further changes. So lots going on here at once. It makes it very, very difficult to be a water manager in Western Canada. So the United Nations took notice of this, and in a couple of years ago proposed 2025 as the International Year of Glaciers Preservation. And it was proposed by the Republic of Tajikistan, which has about 20,000 glaciers, and it's a mountainous country in Central Asia with lots of hydropower. They're upstream of everybody else in Central Asia. And it's really a way to raise awareness of what's going on, of the role of glaciers, snow and ice in the climate system and water systems, and the impacts of this on our economies, on our society, and our environment, and to sort of share best practices and knowledge around the world. And this is the resolution called for it to be implemented by UNESCO, which is the United Nations Education, Science, and Cultural Organization, and WMO, which is the World Meteorological Organization. And being the UN, they gave them a budget of 0 to do this. They said, do it with your existing budget. And both organizations have had massive budget cutbacks recently. The United States quit UNESCO and stopped paying its dues, so that gave them a 20% budget cut this year, and has put strong conditions on the World Meteorological Organization to stop dealing with climate and reduce its budget accordingly. So both UN organizations are on the ropes right now and struggling to carry on, but they are carrying on as best they can. I should say I'm honored to chair the advisory board, co-chair the advisory board of this grouping, and so we're trying to make a successful year. So why did they declare that year? Well, this graphic produced by Saskatoon's Chris DeBeer shows it very, very well. The changes in mountain snowpacks, we're seeing decreased snowpack, snow depth, decreased snow water, darker snow due to soot on the snow and ice causing more rapid melt, more rain on snow events at high elevations, reduced accumulation of snow in the glaciers causing rapid glacier retreat, droughts in the mountain forest causing wildfires, and you think of the Jasper fire last year as a terrible example of that. The changes in how vegetation is responding, the tree species are less healthy than they were in the past, and of course mountain permafrost is in there. It's not well measured, but this is permanently frozen ground in the high mountains. It literally holds them together, and it's thawing, and a lot of mountains are simply falling apart. And there are massive rock falls and rock slides coming out of the Rockies. The one that killed several people this spring above Bow Lake, another horrific example of that. So that's going on without much monitoring. And really, no one has good monitoring of mountain permafrost. And altered river flows. So this is where it hits Saskatchewan in terms of what we see entering Lake Diefenbaker and through the North Saskatchewan River. So, and this is going on around the world. That's our local microcosm, but this could be Nepal, this could be the Alps in Europe, it could be the Andes. And so the impacts are terrible. And the other thing is, if you're on the coast, this is not a good time to live on the coast because of rising sea level rises. And mountain deglaciation has been the largest contributor to mountain sea level rise so far. But Greenland and Antarctic ice sheet melt is starting to kick in, and that will raise sea levels far more. How much more? The most pessimistic and maybe realistic estimates are 1 to 3 meters by the end of the century. So don't invest in coastal real estate anywhere. But it makes coastal cities around the world where most of humanity lives. It makes those locations unviable. It makes whole countries unviable. Small island nation states, the Bahamas, the ones in the Pacific, are expected to disappear completely. And they know this. They're planning for their extinction in many of these countries. Large countries like Bangladesh, with hundreds of millions of people, will be largely underwater with those scenarios. So these are truly horrific. And this is why we have a need to mitigate. And by mitigate, I mean reduce the levels of greenhouse gases in the atmosphere, and as a matter of urgency, but also we need to adapt to this loss of the mountain cryosphere, and we'll get into the cryosphere in a second. So almost immediately, the UN realized that 1 year is not enough to deal with an issue of this scale, and so the General Assembly went back to work, and last year declared this year to 2034 as the decade of action for cryospheric sciences, and cryosphere is the science of snow and ice. So to meet the challenges associated with melting glaciers and declining snowpacks, permafrost, and all the rest around the world, whether it's sea ice in the Arctic, Antarctic glaciers, or loss of frozen ground and soils in Saskatchewan. And in this case, they tasked UNESCO with working towards this. As I mentioned, a very challenging time for UNESCO to put something forward. So they've asked me to, recently asked me to chair the ad hoc committee to get that decade launched, which I'm doing. But we're doing it under very difficult circumstances. So a big question, what is the cryosphere anyway? That's not a word you'll find in many spell checkers as an example, but I think you'll hear more about it over time. It's our snowpacks, our glaciers, our ice sheets, frozen ground, permafrost, sea ice, lake ice, and river ice. So it defines most of Canadian life about half the year, 3/4 of the year if you live up north. But it's defining our water supply, our ecosystems, our agriculture, our hydropower, on and on and on. and our transport systems. So why did the UN create the cryosphere decade? Well, we have the rapid melt and thaw of the cryosphere as the elements that I mentioned, and the environmental, social, and economic losses, and also the fact that science has not caught up with this. We don't understand enough about this to offer the solutions that are needed right now, and that became very apparent in the glacier year. And so this is much like the international hydrological decade was in the 60s and 70s, to rapidly advance hydrology as a science. This is to rapidly advance cryospheric science to meet the challenges facing the planet right now. And you'll notice some artwork in here. The artwork is from a book we just published with UNESCO called The Great Thaw. And The Great Thaw, the artwork is from an artist based in the UK, Gennady Ivanov, who came to Canada. He's a very good artist and came to our attention, so we brought him and took him on a tour of the sites in Western Canada where we were conducting research, and he painted very dramatic paintings. This is the Arctic Ocean, and an artist can show fires over the ocean, so he can do things like that. This is thawing permafrost in the north with the exposed ice and the collapsing trees off the cliff. This is one of our research sites in the Canadian Rockies with a meteorological station in there. So you see a lot of his art in here. Sometimes I can convey the information better than a graph. So again, why? Well, the changes, and this is, for example, simulations we have with a hydrological permafrost model of the Mackenzie River Basin. Edmonton would be about there, Yellowknife's up in there, and Nuvik's up in here. And this is showing the current permafrost cover in that area. Blue is permafrost. The maximum, mean, and minimum estimates from our various modeling perspectives. And this is showing it in mid-century, and this is showing it in late century. The models tend to converge with loss of 90% of the permafrost in the Mackenzie River Basin by the end of the century. So this is disastrous. This is the underlies the communities in the Western Arctic and Mackenzie Valley. This holds the forests up. The forests are on ice-rich ground, and those forests collapse, they die, and they burn. And yet we're talking now about building a Mackenzie Valley highway up through there. How are we going to do that on thawing permafrost, or keep the growing populations of the north in stable, safe communities? So there are tremendous challenges that we're not quite facing yet as a society. So Arctic Ocean sea ice retreat and impacts. We lost about a quarter of sea ice already in the Arctic in the last few decades. We're projected to lose all summer sea ice within the next decade or two in the Arctic, and this is causing the extirpation and collapse of polar bear populations. It's tremendously affecting Inuit communities that hunt on the ice, travel on the ice, but it's also affecting the temperatures and the ecosystems in the Arctic Ocean, causing warming of the ocean, changes in species. The char are on the decline. They're seeing salmon in the Arctic now, further north, and is starting to cause changes in ocean circulation that I'll talk about in a bit. So these changes have tremendous impacts on our northern ecosystems. The cryosphere decade is going to end with another international polar year in 2032-34. And those polar years have been going back. The first one is in the 1870s, then the 1950s, and then we had one in the 2009 period. But these were explosions of research to better understand how the Arctic and Antarctic systems are working. So we need to get a better handle on what these changes are going to mean for the Arctic Ocean. It also means security challenges for Canada, as an ice-free Arctic Ocean becomes easier to transit for ships from many nations, many of whom do not recognize the Arctic archipelago as an inland water for Canada. And so our sovereignty over the north will very likely be challenged very, very soon through this. But it also offers opportunities for us for shipping out of Churchill and other areas if we can maintain the railways across the permafrost to these Arctic ports. That's not a given. So thawing permafrost, as I mentioned, is devastating. It's been described by the Ventokwichin of northern Yukon as a nuclear explosion in slow motion on their ecosystems and way of life. And it is literally destroying everything for them, including their homes. And And the changes in snowpacks, the South Saskatchewan River here is largely fed by seasonal snowpacks in the Rocky Mountains. So it's not the decline of the glaciers we need to worry about here. That's a small portion of our flow already. It's the decline of that seasonal snow that is our main concern. And it's also a massive part of runoff in Saskatchewan. It's typically been 70 to 90% of runoff in Saskatchewan in our creeks and filling our sloughs and recharging our groundwater. So that's where we have to keep an eye on. The declining snowpack has had already implications for hydropower. All the major hydroelectric companies across Canada lost money in 2023 and were unable to meet their planned delivery of hydroelectricity. British Columbia has been importing electricity from Alberta, which is burning fossil fuels to generate it, and from the United States in recent years because they can't, the reservoirs are not up to the planned demand. Hydro-Quebec, very similar. Hydro-Manitoba, very similar. And of course, the low flows you see through the South Saskatchewan River in Saskatoon are very bad news for SaskPower as well, whether it's Gardner Dam or further downstream. This also has impacts on ecosystems. This worried-looking beaver watching the clock, seeing perhaps time running out for filling beaver dams and wetlands. And of course, we've had wetlands burning in northern Canada, the peatlands, as a source of fire, and even zombie fires in the peatlands that keep burning through the winter and flare up again the next summer. So there are massive changes occurring everywhere. This is one of the glaciers that we monitor out of the University of Saskatchewan, is Peyto Glacier. You see this lake here? It didn't exist in 2010. It's a new lake. We're calling it Lake Munro after Scott Munro, a glaciologist who worked there for many years. And Scott and I had an experiment with weather stations on the ice, kind of where from I'm taking that picture in 2008. And we were sort of 30, 40 meters above the ground there on ice. That's all changed. We've been flying laser altimetry from a drone over Peyto Glacier to map its decline over time. And in the last 5 years, its surface elevation has dropped 56 meters in that area there. These other areas, 45, 30, this has dropped less because it simply disappeared and retreated. So the glaciers retreated to this area now from where it was before. So we've had 450 meters of horizontal retreat and over 50 meters of horizontal loss in that glacier. It's one of the few with intense measurements in the Rockies, but like most of them, it's on the way out. It's disintegrating before our eyes. Every time we visit it, we have to replace and re-drill our stations, our weather stations up there, and every route is a little bit different every trip. And it shortly will be, I think, gone probably by the end of this decade. The loss of snow and ice and permafrost releases things that we'd rather stay in the ice. And one are pathogens. In Siberia, they've had people killed by anthrax coming out of permafrost that's 30,000 years old, whether it's in the carcasses of animals that were frozen in the ice and are revealed there, or through direct exposure. But it's entered the human population in Siberia already. In the Tibetan Plateau, Chinese scientists and scientists in the US have measured 1,600 novel viruses coming out of the ice cores in the Tibetan Plateau. So these are ones unknown to humanity beforehand. So lots of things that we don't know much about are coming out. And then I did a bit of reading, and it was interesting. In the 1330s, there was the first recorded case of the Black Death, and it was in the Chen Mountains of Central Asia, where there was a Nestorian Christian community that was killed off by this. They buried their dead, and the bodies have been sampled, and it showed that they died of the plague. They were downstream from the Ala Archa River and the Chen Mountains, which were undergoing an extreme warm period at that time. It was still the medieval warm period, and high river flows. So it was rapid ice melt, high river flows, and the start of bubonic plague. So we can't prove that's what happens. We don't have enough information. But it's an interesting linkage to these things, that diseases can come out of melting ice. The problem is that we don't know anything about our immunity to these ancient or novel pathogens, and we don't monitor it in any way. So it's one of these unknown unknowns that's a risk that could be posed for the future for animal populations that we depend on, or even ourselves. So for the decade of action for cryospheric sciences, there are 5 overarching challenges they're trying to deal with. One is better monitoring of the cryosphere, more weather stations, stream gauges, permafrost monitoring, checking for pathogens coming out of the glaciers, better glacier monitoring. Not just in Canada, and we need more, but other parts of the world need vastly more. In the Himalayas, the Tibetan Plateau, Central Asia, the Andes, high mountains in Africa, these are areas where we really don't know much of what's going on. We have to be able to predict what's happening globally, and that means developing the computer models and simulations that can do this, and looking at them to come up with risk scenarios and help decision makers make good decisions. We want to develop cryosphere hazard maps, develop early warning systems for things like glacial lake outburst floods or rain on snow floods, such as hit Calgary in 2013. And then work with indigenous communities and other communities to help with adaptation strategies, mobilize knowledge better, and then also communicate the risks this is posing to the world so that governments can make informed decisions about their greenhouse gas emissions and other factors. So that's a big challenge. How do we address this? Well, one is by observations, and this one group I lead deals with high mountain observations around the world. These are what they look like, and these are where they are. But we need to have more of these. They're not enough. We also need new satellites that measure snowpack in the mountains, river stage and storage, and open sharing of data. There was recent flooding in Nepal. They hit the Nepalese without warning because the Chinese authorities didn't share anything about flood coming downstream. It ironically washed out the peace bridge newly built between Nepal and China. So we have to share data more openly, and we're not doing that very well. Canada's fine, but it's not fine in Asia. The one thing we're doing for observations is the universities across Canada have banded together, and there are more being added to this list for something we call the Global Water Futures Observatories. And this is a freshwater early warning system for Canada. It's headquartered at the University of Saskatchewan. We have lots of sites in Saskatchewan, a bunch in the Rockies, in the north, in the Great Lakes region, and it's measuring everything from water quality in Buffalo Pound Lake and algae blooms in there to the soil moisture conditions in the boreal forest, right up to one of our stations burning down this summer, by the way, to the melt of the Rockies glaciers, to the algae blooms in Lake Erie and conditions in the Great Lakes. So it's a national network and it's growing. That's one solution along with the federal networks. In Saskatchewan, we go down from the irrigation districts in Buffalo Pound up through the dryland farming in central prairies up into the north, through the boreal forest, and then in the Rockies. And these are the stations that we operate in our domain. So observations are not enough, though. You can't observe everywhere, so you need to be able to predict and to diagnose what's happening, and that's where computer models come in. And these allow us to look at things like the future flows of the Athabasca River near Jasper, if it kept glaciers, and then in magenta, if it lost its glaciers, which it will. So a collapse, and this is the current stream flows in there, or the flows out of Peyto Creek into Peyto Lake, which with deglaciation and climate warming also become much lower in the summer. So it allows us to understand what that future will be and then plan accordingly with models like that. The early warning systems can extend to really novel things. This is a system called the Canadian Hydrological Model. It's a snowpack prediction system developed by a student of ours, mine, Chris Marsh, who now works for Environment Canada in Saskatoon. But that can allow us to predict the stream flow and the snow conditions in detail across Western Canada, and it's scalable to the world. But we need more of these, and we need to provide early warnings of extreme events coming from this as well. Alberta Environment's already using this system to help them with their water supply forecasts. In Canada, we developed the MESH model, Canadian Hydrological Model with Environment Canada, and we've been able to apply that over large areas around the world and deal with and put in the processes that we feel are necessary in here. A lot of this came out of the cold regions hydrological model, also developed at the University of Saskatchewan. And so we're making these products available around the world to help with prediction. This is showing some results for the Yukon River Basin in northwestern Canada. And it's a big basin, starts off in BC, flows through Whitehorse and Dawson City. Then in Alaska, it covers central Alaska down to the Arctic, to the Bering Sea. It's 75% of it's covered with permafrost, and it has very high ice levels. And here's the permafrost predictions out of the model for the far future by the end of the century. Going forward, all the model results converge, and only 3.5% of the basin will be covered in permafrost by the end of the century, it looks like, under climate warming that we anticipate. So this is dire, so visit Dawson City now, because it's not going to be standing much longer as places like that, the communities, the highways, the Dempster Highway, all this gets destroyed by thawing permafrost. We've also run these on the Saskatchewan River Basin, and here we have to take into account irrigation in Alberta and Saskatchewan and reservoirs and human consumption as well. But looking at that basin, we can look at and diagnose how the hydrology operates with most of the runoff generated in the high mountains and not much on the prairies, but most of the evaporation occurring on the prairies out of crops. And so that mismatch means it's very important sometimes to irrigate parts of that region where possible. So this is how it has been, but we can also look forward to what it will be, so the future hydrology there. And basically peak flows occurring much earlier, some cases 76 days earlier, but the change in volumes generally going up in throughout the basin. But summer flows declining quite a bit through there as well. So earlier peaks in the spring, higher peaks because of rainier springs and winters, but much drier summers resulting in lower peaks, and deglaciation making this worse. So we need to get our act together as a country, and I was happy to be visiting Ottawa 2 weeks ago and seeing that they're moving forward on a private member's bill to establish a national strategy for flood and drought forecasting, because we need to have some early warning of what's occurring, and we need this right away. And we do this provincially right now, which means 13 provinces and territories, each individually, try to predict and forecast their water resources. And some provinces are big and rich and do a good job of it, and some provinces are poor, or territories are poor and sparsely populated and don't do it at all. So it's very uneven across the country, despite the fact that we have shared river basins across the country, like the Saskatchewan or the Great Lakes, St. Lawrence, and that we share water with the United States. So this is something that needs national attention. And so the bill's hopefully moving its way through Parliament, and would assess opportunities to develop flood and drought forecasting across Canada to meet the information needs of the provinces, municipalities, industry, Indigenous communities, and others, and to help map floodplains more accurately, because these are all changing on us very rapidly. Techniques that were developed 20, 30 years ago, or even 50 years ago for the floodplain mapping programs are no longer valid. We have to revisit all of this. So this is crucial. So what can we do? So climate change is coming. We've got to reduce greenhouse gases. It's not going to be fast enough to save our mountain glaciers and much of our snowpack and all the rest. So we try to predict them as best we can, and internationally get the agreements in place that will reduce that. But in the meantime, we have to protect our society and our ecosystems, our economy, through better predictions, and we have to adapt to changes. This is a dust storm, a real dust storm, out of Kinbasket Lake in British Columbia, part of the Columbia River system, after a drought in 2023. So that's not an artist's imagination. That's what the artist saw in that scene. And this is the breakup of Peyto Glacier, which is going on with the wildfires around it. So there's lots to do. Hope isn't lost. The river won't be going dry, it doesn't seem, because of the increase in rainfall, but it's going to be vastly, vastly changed from anything we've seen. And we have to up our game to manage water in this very challenging century. And other countries are going to have far worse outcomes than Canada. Central Asia looks like a drop in stream flow of 40 to 45%. Long-term drought and desiccation of the southwest, south-central United States. So other countries will be looking to us for food and for places to live. And when you add sea level rise to that, it could be many, many other countries. So we've got to be ready for this because we're going to see challenges that no generation has seen in the history of our species. So anyway, thank you very much.